Hello and welcome to today's lesson on acceleration. So for starters, imagine you are a race car driver. You push on the accelerator, and what happens when you push the accelerator in a car? Your car goes forward, moving faster and faster. As you approach a turn, a curve in the track, you take your foot off of the accelerator, which allows you to make the turn. In both situations, you changed your velocity. The first one, your speed increased, which meant your velocity changed, went up. It also changes if you decrease speed or change direction. So we're going to talk about that today with acceleration. And so vocab-wise, when you change your velocity, it undergoes what we call acceleration. So the definition you need is acceleration is the rate at which velocity changes over time. So the rate at which velocity changes over time is acceleration, and that's going to be an important definition for you to know. An object will, not acceleration, object will accelerate. Accelerate. If its speed, direction, or both change. So there's a couple ways we can accelerate. And we'll talk about those today. The first way it can accelerate is a change in speed. So for example, in the diagram below, imagine this is you on a bike. Every second here, so we start at 1 second, we are going 1 meter per second, 2 seconds, 2 meters per second, 3 seconds, 3 meters per second, 4 seconds, 4 meters per second, and 5 seconds, 5 meters per second. So each second you're getting faster. Every second your velocity increased by 1 meter per second. So again, here's your breakdown. Your acceleration can be stated as an increase of 1 meter per second. So every second your velocity went up by 1 meter per second. Or we can take this unit here, we can combine the 2 seconds and call it meters per second squared. In both cases it needs the direction of south, because we're doing linear velocity, linear motion, and we're changing just our speed, so we can keep this direction here. Another way you can accelerate is a change in direction. So remember, your definition for acceleration was a change in velocity divided by time. And so because these skaters, this is short track speed skating, they're going in a circle. Because these skaters are changing their direction, they are accelerating. So again, this is a change in velocity. Remember, velocity is speed with the direction. And since velocity is both speed and direction, your object will accelerate if either or both change. And so that means you can actually accelerate while never speeding up or slowing down. So you can be in a car taking a corner at the same speed, and you are accelerating, although most of the time we think of speeding up. Speeding up, slowing down, or changing direction are all ways you can accelerate. If you move at a constant speed in a circle, again, even though your speed is never changing, your direction is always changing, you are accelerating. You are always accelerating, constantly. This kind of acceleration, this kind of motion, so acceleration that occurs in a circle or in circular motion is called centripetal acceleration. So remember, with centripetal motion, we've talked about it. But centripetal acceleration, centripetal means center seeking. So each time, what's happening to these blades is they're moving in a circle here. That they're continuing to go in the same circle all the way around, but they're actually accelerating towards the middle. So this blade is trying to go towards the middle, but because it's got a velocity going horizontally, it's going to go in this circular motion. So this is center seeking or centripetal acceleration. Examples of this, places we see this. The moon goes around the earth, revolves around the earth. That is, the moon is constantly falling towards the earth, being pulled towards the earth. It just misses continually. Motorcyclists inside a large barrel, they can stay up. Rolling around the earth. Motorcyclists inside a large barrel, they'll stay on the side of the barrel. And then Ferris wheels do the same thing, constantly being pulled towards the center, just never getting there. So earlier we talked about acceleration being a change in velocity over time, and we can make this an equation. So to find the acceleration, you need to find the velocity. So to find acceleration of objects moving in a straight line, you need to find the velocity at a couple different times. And we can calculate what's called the average acceleration. Average being, if this were done at the same rate the entire time, this would be your average acceleration. And this is given by taking the time interval and dividing your velocity by that time. And so we can have an equation which is acceleration equals final velocity minus initial velocity divided by time, which if we write letters and variables, we get A equals VF is final velocity minus VI is initial velocity, all divided by t. And this VF minus VI is the same as triangle V. And this triangle is actually a Greek letter delta, which means change in. So this is your change in velocity divided by time, which is VF, final velocity minus your initial velocity. That's going to give you your change. And we'll practice using this here shortly. So looking again at acceleration, if it is small, if you have a very small acceleration, your velocity change is going to be very gradual. Hard to notice, maybe not noticeable at all, maybe you will, but it's very gradual. If your acceleration change is large, your change is going to happen more rapidly, and this is typically a more noticeable change. For example, a person accelerates at a rate of 2 meters per second squared, whereas if you're in a sports car and you stomp on the gas pedal, you can accelerate up to 7.2 meters per second squared. So a person can go from 0 to 2 meters per second in about 1 second, and 2 meters per second to 4 meters per second in about 1 second. A car can go from 0 to 7.2 meters per second in 1 second, and from 7.2 to 14.4 meters per second in 1 second. That's a much bigger jump, a much more noticeable jump. A couple more pieces. If your acceleration is positive, this means you are increasing your speed, your velocity is increasing, you're speeding up, you're going faster. If your acceleration is negative, your velocity is decreasing, which means you are slowing down. So a lot of people use the term deceleration. In this class, we're not going to use that. We're going to say a negative acceleration instead. So here's an example that you have a person on a bike. So if acceleration is the rate at which velocity changes, the person on the bike is slowing down. He starts at a speed of 5 meters per second, so that's his speed there, and slows to 1 meter per second over the time of 3 seconds. So here he's going 5.5 meters per second, here he's going 1 meter per second. And it went from 1 second to 4 seconds, so there's my 3 seconds. So if you run the equation, you get A equals your final velocity, which is 1, minus your initial velocity, which is 5.5, and divide it by 3, you're going to get 1 minus 5.5, which is negative 4.5. This is negative 4.5. And divide that by 3, you're going to get negative 1.5 meters per second squared. And remember that negative sign indicates that he is slowing down. So a change in velocity is negative because he is slowing down. And this makes his acceleration negative as well. So that is how you use the equation. We're going to practice that in the next video. But before we do that, I just want to remind you there are 3 ways you can accelerate. 1, you can push on the gas pedal, you can speed up. 2, you can push on the brake and you can slow down. Or 3, you can turn the steering wheel and you can change directions. So the 3 ways you can accelerate are to speed up, to slow down, or turn are your 3 methods. Thank you very much for your time and attention today. I look forward to working with you tomorrow as we progress through acceleration.